Okay, so the other thing that this Jamboard wants you to do is include a sticky note. So this sticky note is going to explain some of the features that you put into your activity to complete the challenge that was asked of you, what your thought process was to make the effect that you wanted. So I want to make sure that every slide doesn't just include a screenshot, but your actual reasoning behind why you did what you did. So the first slide here shows a very simple representation of electric fields. One is the electric field of a positive charge and the electric field of a negative charge. So these little sticky notes are explaining what's happening or the reasons why. And here it says the positive charges have fields that point away from them, while the negative charges have fields that point toward them. Well, electric fields are an extension of everything we learned about how charges interact, how like charges will repel and opposite charges will attract. It'll also reflect how distance can play a big part on the magnitude of the force or the amount of force that is felt when they're far away versus close together. And so, if you relate this to what we've learned, if the electric field lines are pointing away from a positive but into a negative, that is very similar to the force that is felt from a positive charge. We call this a positive test charge when you have a charge in this electric field interacting in the direction of the electric field lines. So the electric field lines are representative of the force that a positive test charge will feel when it is in the vicinity of this positive or negative charge and the field that is created by that charge. So this is the basics of electric fields when you have one charge. I want to show you what it looks like here because, first of all, it's always helpful to include the grid and the values. But I want you to notice that when you have a positive test charge, it doesn't just show the arrows moving away, but it also shows the arrows starting off pretty bright and then getting dimmer and dimmer and dimmer, which again is representative of the fact that the force that electrostatics create is much stronger the closer you are to that electric charge, and it is much weaker. That force is much weaker the further away you are. It is a inverse squared relationship, as we learned in our Coulomb's law lab. So the sensor here is going to tell you what that force is. So again, the electric field shows it through brightness, but the sensor actually shows the force through the magnitude of this arrow and this number value here, which is kind of hard to see because it's hidden. But the 36.4 volts per meter is another representation of the amount of force that this test charge, this positive test charge, is feeling in this electric field. So notice the closer it is to the positive charge, the stronger that force is, and therefore the longer the vector is. And it is wanting to repel, which is why the arrow is always pointing away no matter where I place it on the field. And then again, further away, the smaller the arrow because the smaller the force. If I switched it to a negative charge, it will not repel, but attract. So it's small when it's far away, but it's going to get stronger and stronger the closer I am. And it's always going to point in toward that negative charge. So you're going to play around with these charges. Always go back to your understanding of how charges interact. It's going to ask you to include multiple charges. So when you include multiple charges, the field's a little more complex. I'm not going to go too complex, but let's say I have a positive and a negative charge here. Well, it follows the same principle, away from the positive into the negative, and the arrows, because of this interaction, create these nice little loops out of the positive into the negative, out of the positive into the negative. And then out here, the force is much smaller, but it's still following that same pattern out of the positive and into the negative. So when you're doing these activities, you can always reset it to start over. You can always, you'll always want to add grid lines and values. Those are always helpful. Positives, if you want to take it away, negatives, and of course, this is a positive test charge, which shows the magnitude and direction of your force when you have a positive interacting in an electric field. So, you're going to take your screenshots as I showed you before. You're going to embed them in your appropriate slide. And then once you're done with this, every group member is going to submit the URL onto Canvas. Once you're done with that, you are going to, and you have a good understanding of electric fields, you're going to get into the next activity. So this one is the worksheet that you're collecting, that you collected earlier today when you walked into class. And this one is going to take your understanding of electric fields and have you try to get this positive test charge into the goal. So it's essentially playing hockey with charges. It gets a little more complicated because now you've got some obstacles and you can pull in as many. Well, let me show you. Here's the link on Canvas. And you can add as many charges as you want, depending on the challenge, obviously. It gets harder when you have a limited amount of charges that you can include. But as I showed you before, the more charges you have, the more complex your electric field. And this test charge is going to be feeling those forces from all the different charges. To make things easier, if you don't want to be too challenged, you can include the electric field lines in there as well. And when you're ready to see how this charge interacts, you just press start and then it'll move in the direction that your electric field wants it to. So obviously I didn't move it toward the goal because I didn't want to give the answer away, but you get the basic idea. Your challenge is going to have to be observed by Miss Lee because there's no way of me knowing that you actually did it unless we see in real time that you got it done. So you're going to get a stamp for every challenge that you complete. And then if you finish early, there's a bonus level. We only actually have you go through level 1 with one obstacle, level 2, and then if you just want to have fun and really try to challenge yourself, go ahead and do level 3. It's not worth any points, but it's just some students really enjoy the challenge of it. So feel free to do that when you start a new activity or you don't hit the goal. Always hit reset, always hit clear, then reset, and then you can start putting in your charges again to set it up the way you think it should be. So good luck with this activity. Miss Lee is a physics teacher. She is a student teacher with Miss McGarry, so she knows a ton about physics. She'd be happy to guide you without giving you any answers. So feel free to ask her any questions, and feel free to email me if you have any questions as well. And I'll see you all on Wednesday. Bye.